Hello, this video is for IXL 8.X.1. It is titled Solutions to Inequalities. And the 3-character code for this activity is Golf 2 Uniform. So it says, which of the following are solutions to the inequality below? Select all that apply. Well, be careful whenever it says select all that apply. There could be more than one correct answer. So you could go through and substitute in each of these. You could put -10. And is -3 less than -10? Actually, it's the other way around. -10 is less than -3. So this first one doesn't work. And then the next one, you could substitute in -11. Well, -3 less than -11? Certainly not. -3 is actually greater than -11. So that one's not going to work. The next one is -12. And I don't think things are going to get much better here, because -3 is less than -12. No, -3 is actually greater than -12. So this one doesn't work either. And so apparently it must be the last answer, correct? So we'll substitute in -1. And is -3 less than -1? Indeed, that is correct. So another way to do this that I kind of like, especially whenever you have several of them that could be possible, is to go ahead and just on a piece of scratch paper, if you have a piece of scratch paper handy, just draw out a number line real quick, graph that point, and on this one here, I would rather think of this as A on the left, -3 on the right, and then let's switch the sign. It's pointing at the 3, so let's keep it pointing at the 3. And so you would graph your -3 on your scratch paper and realize that should be a solid dot, and then it's everything to the right. Everything A greater than -3. So everything that's greater than -3 is to the right. Then if you were to plot these other numbers, we know that down here someplace is -10, and then we got -11, right? If we keep our line going, and then we got -12, and then someplace along here we have -1. Well, you can see the only one that is to the right of 3, and this is the side here that we're graphing, right? Everything in here going that way. Well, the only one that's there is -1. So you can substitute if you like. My personal opinion is to graph it and then look at the other numbers and see where they fall on it, and are they part of the solution. So we'll go ahead and look at the next one. And if I had a number line there, and then I plot my -3, -3's here, and just for reference sake, we'll put 0 there. And so now it's n is greater than or equal to -3. That would be a solid dot. And it would be everything, and I'm going to change the color here. It'd be everything going this way, right? Everything to the right of -3. So if I start plotting these points here, well, -3 is right on, so that's a solid dot, right? So this one would be a correct answer. -7 is going to be down here someplace. -9 is going to be even further down. And -10 is going to be even further down. So there's only one correct answer here. Plus, whenever it says which of the following is a solution, that's singular. Notice it doesn't say select all that apply. And so A is singular, so it says which of the following is a solution. So usually this is a good clue that there's just one correct answer. Usually the ones you got to watch for is whenever it says select all that apply. So on this one here, we could substitute it in. I would rather solve this one, graph it, and then see what numbers work. It's going to be a little bit easier than doing the math of all of it. Like, for instance, if I put in 18 here, then I'm going to have 1 less than equal to, in this case, 1, right? Well, we have the equals concept, so 18 does work. And then you'd have to do the math again, and you'd have to do 126 divided by 18, and that's going to end up with something that's definitely greater than 1, right? So if you think about graphing it instead, let's do it that way. And whenever we graph it, and this isn't going to take too much to solve, right? 1 less than equal to h over 18. Well, multiply both sides by 18, right? You won't really even have to write this out. You could probably kind of picture this in your head, and you're going to end up with the h here, because the 18's cancel, and 18 times 1 is 18, and you like your h on the left, and your 18 on the right. It's pointing at the h, so let's keep it pointing at the h. So you would end up finding 18 on your number line, right? And then everything less than. So we're talking about everything that's down in this direction, right? And also it could be equal to 18. So that would be solid dot and everything going to the left. Now if we start plotting our other points on here, well, 18 did work. We saw that whenever we substituted in. But 126, that's going to be like way down here on the number line someplace. And 72 is going to be way up here somewhere. And 36 is going to be around like here. And we see that all of these numbers here, they're not part of the solution because it's going to the left, right? It's everything less than negative 18. So if you had to test a bunch of numbers to find out, I think it would be better to solve it and then go ahead and plug it in. That's pretty much why I put this activity at the end of it. Notice that it was at the beginning of it. Let's see, what was that? Section X. It's 8.X.1. So this is at the beginning, and the idea is that you would plug it in and do the math on it. But I kind of save this to the end because if you can solve it, then you can go ahead and graph it, and then you can evaluate several numbers at once without having to do all the math. Okay. Here we have h over 25 less than or equal to negative 5. Well, if I solve this, I need to multiply both sides by 25, right? Point and times 25. So the 25s would cancel each other. I end up with h and less than equal to, and negative 25 times 5 is going to be a negative 5 times 25 is going to be a negative 125. 5 25s is 125. So if I had a number line, and I would have, say, 0 here, and down here I got negative 125. Now I know everything less than, so in this case, or equal to, so it could be negative 125 and everything that away, right? So now we can start plotting those points and see which ones are in the solution. Well, negative 125, yep, right there on it, right? So this one's good to go. That one works. What about negative 50? Well, negative 50 would be like, what, right here? So that's not going to work. Negative 100, I don't know what negative 100 is going to be like right around there. That's not in the solution. And negative 25 would be right there on the number line, and that's not the solution. So the only one that works is the first one, right? On the next one, we could go ahead and plug in numbers and start checking them and so forth, but I kind of like the idea of just solving for it. So if I have, my first step is going to be what? Subtract 9, right? Minus 9. And so I would have, the 9's going to cancel each other, right? And the 59 minus 9 is going to be 50. And so now I have, let's plug this negative 124 sign up here. So negative 124 over b. Now, we really haven't gotten this far in algebra class. You're so used to seeing the variable in the numerator and not the denominator. And how do we get rid of fractions? Well, we multiply by the denominator, right? Well, we can still do the same thing. We can still multiply by the denominator and it'll get rid of the fraction. Let's try that. So we're going to multiply both sides by, yes, they're tied by division, and we're still going to use multiplication to undo it, but it might seem a little awkward because we've always been multiplying by a number, but we're going to actually multiply by the variable of b. Multiply both sides times b. The b's will cancel each other, and you're like, well, if the b's cancel each other, then what are we going to do? We lost our variable, right? No, it's over here on the right. We now have 50b. Now, if I go ahead and divide both sides by 50, and then I'm going to end up with just b on the right, and then negative 124 divided by 50, that's not going to come out nice. That's going to be like just right around 2.5. So I have negative 124, negative 2.5, negative 124 divided by 50, and that's going to give me a negative 2.48. And remember, I like my variables on the left, so I'm going to put my variable on the left, negative 2.48 on the right, and it's pointing at the b, so I'm going to keep it pointing at the b. So now if I graph this line now, I guess I can put my calculator down. If I graph this line here, and we'll throw 0 right here for reference point, And over here I have negative 2.48. Now let's start plotting everything on the number line. Oh, I need to pay attention to which way it needs to go, right? So let's go ahead. It should be a solid dot because it has the equality portion, and it's everything less than, so it's pointing to the left. So now let's go ahead and start plugging these numbers on the number line. Well, 2 would be right here. That's not in the solution, so 2 is not going to work. Negative 4. Negative 4 is further down, right? It's going to be down here, right? So this is part of the solution, so that one's going to work. That one's good to go. A positive 1, that's up here out of the solution, so that's no good. And then negative 2. Well, negative 2 is actually right here before negative 2.48. Negative 2.48 is further away from 0 than just negative 2. So that's not going to be part of the solution either, so it happens to be that the second selection is the only correct answer. Here we have let's see. Now, whenever they say yes or no, you've only got one number to deal with on something like this here. My suggestion at this point would be go ahead and plug the number in, right? Rather than solving, because if you're going to have to do some math to solve the equation anyhow, if you're just wanting to know yes or no, whether or not it's a solution to the inequality, then if you got to do the math for just one number, probably about the same amount of work as solving it and then graphing it and then plugging all the numbers in. Okay, so we'll go ahead and we'll actually work this one out. 6 is less than 3 minus, and notice we're going to put in negative 123. I'll actually write this out for now. Minus negative 123 over 41. Now minus a negative is the same as plus a positive, so I could actually write this as 6 is less than or equal to 3, change the sign to addition, then take the opposite of the next number, so a negative 123 over 41 becomes a positive 123 over 41. Now I got my 6 less than 3 plus, and 23 divided by 141 is going to be roughly about, I think that's 3. Yeah, it is 3. Yep. And because 3 times 41, 3 times 40 is 120. 3 times 1 is 3. Together they're 123. So that's my mental math there. And so I end up with 6 less than or equal to 6. So I do have the equal portion, right? So equal is fair. It can work. So it turns out to be that, yes, that indeed is a solution. J equaling 123 is a solution. Here we have negative 9 is less than 11 plus 2n. Well, where n is, I'm going to use parentheses. We did this in other classes quite some time ago. The multiplication there, wherever the variable is, I'm just going to put parentheses and then plug whatever n is in. That sounds strange. But at any rate, so I got negative 9 is less than 11, and then plus 2 times negative 5 is going to be negative 10. So that's the same as 9 is less than 11. Change the sign to subtraction, take the opposite. Remember, we can change the sign and then take the opposite of the next number. And that might simplify it a little bit easier to see that this is actually 11 minus 10, and that's 1. Is negative 9 less than 1? Well, if we graph that, here's 0, here's 1, and down here's negative 9. Well, negative 9 is further to the left of the number line, so indeed negative 9 is less than positive 1. So the answer is yes, it is indeed a solution. Which of the following are solutions? So it could be more than one. Select all that apply. So we'll go ahead and on this one here, again, I'm going to go ahead and just solve it, right? And then plot it out on a number line. So 33 less than or equal to 30 over g plus 4. So let's go ahead and subtract 4 from each side. So minus 4, and that's going to give us 29 on the left, less than or equal to. The 4 is going to cancel, and I'm going to end up with 30 over g. So here I am again with the denominator. The number at the bottom of the fraction is a variable, and I want to get rid of the fraction, so I'm going to multiply by the denominator. And the denominator happens to be the variable g, but what I do to one side, I'm going to do to the other. So I end up with 29g on the left, less than equal to, and the g's cancel, and I get 30. And then divide both sides by 29, right? and 29 is going to cancel, leaving it just G on the left. And then this is going to end up being 30 divided by 29. It's going to be like 1.1 or 1.0 something. It's going to be really close. 30 divided by 29 is going to give me 1.03. 1.03. So it's just a little bit more than 1. So with that said, I'll graph my line there. And here's 0. Plot 1.3. 1.03 right there. And it could be equal to or greater. I should change colors, right? Equal to or greater. So it's everything going this way. So now we can start plotting those numbers and see which one's which. 1 is actually going to be before it, right? It's just before. 1 is just before 1.3. So 1's not going to work. 2 is actually after it. So 2 would work. Good to go. 6 is going to be further down. Good. And 5 is going to be like right in this area right here, right? So 5 is also good. 2, 5, and 6 all fit in that area. Now see where we had 3 correct answers? And this is one of those times where I say, I think personally it's easier to solve it, graph it, and then see where they fall in the line rather than doing 30 divided by 1 plus 4, 30 divided by 2 plus 4, 30 divided by 6 plus 4, 30 divided by 5 plus 4. And as I say it, that one really wouldn't be too bad, honestly. Not too much difficult mental math there, really. But on this one here, let's go ahead and let's do it the other way. Let's substitute it. I've been solving and graphing. I think I've showed that way quite a bit. We could go ahead and substitute this in. What if it's a 6, right? So we have negative 10 less than and negative 9 minus 6, which is the same as plus a negative 6, right? Change the sign, take the opposite. So negative 9 plus negative 6 is negative 15. And is negative 10 less than negative 15? No, that's not a true statement. Negative 10 is actually more. So 6 doesn't work. And again, and I strongly encourage you to use a piece of scratch paper and work these out. Sometimes whenever you try to do things in your head, it kind of gets mixed around. So let's take the minus a positive. Let's turn that into plus a negative. Right, and so we see that we have negative 10 less than negative 9 plus negative 3 is going to be a negative 12, right? So is negative 10 less than negative 12? Nope, that's not true either. Negative 10 is actually greater than negative 12. So the first two don't check out. On the next one, we could plug in a 7. So let's make this plus negative 7 instead of minus a positive 7. Make that plus there. So we end up with negative 10 less than negative 9 plus negative 7. It's going to get even more negative. And we end up with negative 16. Is negative 10 less than negative 16? No, negative 10 is actually greater than negative 16. So hopefully it is the final answer. Seeing how it's a negative over here, I'm going to guess that it is. And so I have, instead of R, I have negative 7. And so let's take this to, instead of minus a negative, let's make that plus a positive. So we can get rid of, and I need a tiny eraser there. Squeeze that in right there. So we'll go ahead and make that plus a positive 7. And so we have negative 10 less than negative 9 plus 7 is going to be negative 2. Is negative 10 less than negative 2? Indeed it is. So if you want to go ahead and substitute it in, you could do it that way as well. So here's my final 2 questions on this one here. Is R equals negative 1 a solution to the inequality below? On this one here, we want to go ahead and substitute it in instead of solve it. Probably not as much work there. So negative 9 minus, I'm just going to rewrite. Let's go ahead and rewrite 72, substitute in the value of R is negative 1 less than 13. So some algebra steps here, mathematical properties in play here that are going to make this a little bit easier. And I'll show you each step. So I'm going to go ahead and keep the negative 9 and the minus. Now 72 over negative 1 is the same as negative 72 over positive 1. It's kind of like you just move that negative sign out of the denominator into the numerator, right? And less than 13. Now, my brain's doing mental math way ahead, and I'm just going to go ahead and keep this simple here. So let's go ahead and change the sign, all right, plus, take the opposite of the next number. So instead of a negative 72 over 1, let's make that positive 72 over 1. Bring down our less than 13. Now I could do negative 9. And I really could have done this in my head a lot faster, but I want to show every step so that you understand where I'm getting to. And that is 72, because 72 divided by 1 is 72. It's less than 13. And then negative 9 plus 72, well, that's going to take us way past 13 there. We know that we're adding two numbers where one's negative, one's positive. So we actually want to do 72 minus 9. It's going to give us 63 and 63. And the 72 has the greater absolute value and it's positive. So our answer is going to be positive. So we'll leave that 62 as positive and 13. Now, is this statement true? There's a lot of work there, right? But I could have done it a little bit faster, but I wanted to show you every step along the way. So 63 less than 13, that is not a true statement. So the answer is no, this is definitely not correct. On this one here, probably be easy enough to go through and check those. But again, I like my variables on the left, my numbers on the right, and it's pointing at 1. So let's make it continue to point at 1. Now if I were to graph that, right, and I have 0 here and 1 here. And so I want to go ahead and graph that real quick. It does have the equality, so it should be solid dot. It's pointing to the right. It's all numbers greater than 1. And now I could plot out these remaining numbers here. 5, yep, 5's down here. It's good to go. It's in the solution. It works. 3, yep, 3's around here someplace. It's good to go as well. 8, it's even further down over here. So it's good to go. And then 6, which is going to be like right about here. It's good to go as well. So as it turns out to be, all 4 of these values could be solutions to that inequality. All right. Those are all of my examples for IXL 8.X.1, solutions to inequalities. Good luck with your activity.